Yo, what's up everyone? Welcome back to Space Fact Fusion. Today we're diving headfirst into a topic that sounds like it's straight out of science fiction, but trust me, it's very real and it's going to be huge. Quantum computing. We're talking about computers so powerful they make our current machines look like, well, pocket calculators from the Stone Age. We're going to break down 10 mind-blowing facts about quantum computing that'll give you a glimpse into the future. From revolutionizing medicine to breaking the internet, hopefully not literally, quantum computing is about to change everything. So buckle up, smash that like button, and let's get right into it. Alright, first things first. We gotta talk about what makes quantum computers so special. These aren't just your everyday machines. They are a whole new breed of technology that's set to revolutionize the way we process information. And it all starts with the qubit. This tiny unit is the heart and soul of quantum computing. See, our everyday computers use bits which are like tiny switches that can be either a 0 or a 1. These bits are the fundamental building blocks of classical computing. But a qubit? It's like that switch can be a 0, a 1, or both at the same time. This phenomenon is known as superposition. That's called superposition. And it's one of the keys to quantum's power. Imagine being able to perform multiple calculations simultaneously. Think of it like this. A regular computer is like flipping one coin at a time. Each flip represents a single calculation, heads or tails. That's it. It's a binary outcome, just like the bits in classical computers. But a quantum computer is like flipping a bunch of coins that can land on heads, tails, or somehow both at the same time. This creates a vast array of possibilities. That's a lot of possibilities, right? This ability to handle so many outcomes at once is what gives quantum computers their incredible potential. This lets quantum computers crunch through certain problems way faster than regular computers. We're talking exponentially faster. Problems that would take classical computers years to solve could be tackled in mere seconds. But here's the catch. Qubits are super sensitive. They need to be in a perfectly controlled environment to function correctly. Think of them like that one friend who's always getting distracted. Any little disturbance can throw them off. Any little disturbance like heat or vibration can mess them up and cause errors. This makes maintaining qubits a delicate task. So building stable and reliable quantum computers is still a huge challenge. Scientists and engineers are working tirelessly to overcome these obstacles and unlock the full potential of quantum computing. The future of computing is incredibly exciting, and quantum computers are at the forefront of this technological revolution. As we continue to make advancements, who knows what new possibilities will emerge? Now you might have heard about this thing called quantum supremacy. It's a term that's been buzzing around in tech circles for a while now. Basically, it's the point where a quantum computer can solve a problem that would take a classical computer an impractical amount of time. Imagine a task so complex that even the most powerful supercomputers we have today would need thousands of years to complete it. Back in 2019, Google made headlines claiming they'd achieved it with their Sycamore processor. This was a monumental claim that shook the tech world. They solved a specific problem in minutes that would have taken a supercomputer thousands of years. This problem involved random number generation, a task that, while complex, isn't necessarily useful in everyday applications. Sounds impressive, right? And it was a major milestone. The scientific community was abuzz with excitement, and the media was quick to label it as a breakthrough. But some people argue that the problem Google solved wasn't exactly the most useful one in the real world. Critics pointed out that while the achievement was technically impressive, it didn't necessarily translate to practical applications. It's kind of like building a super fast car that can only drive in circles. Sure, it goes really fast, but it doesn't get you anywhere meaningful. Impressive, sure, but not exactly practical for your daily commute. The real challenge lies in making quantum computers solve problems that have real-world applications. The real test is whether quantum computers can tackle problems that actually matter to us, like drug discovery or material science. These are areas where quantum computing could truly revolutionize our world, making a tangible difference in our lives. Okay, this next one's a bit scary. Remember how I said quantum computers are good at solving certain problems? Well, one of those problems just happens to be breaking the encryption that protects pretty much everything online. We're talking bank transactions, personal data, government secrets, the whole shebang. Right now, most online security relies on algorithms that would take classical computers millions of years to crack. But a powerful enough quantum computer could potentially break them in a matter of hours or even minutes. Yikes. The good news is, researchers are already working on quantum-resistant encryption methods. It's like a cybersecurity arms race. With the future of online privacy hanging in the balance, the stakes are high, but hey, at least it's exciting, right? Now let's talk about AI, the technology that's revolutionizing our world. You know, the thing everyone's either excited or terrified about? It's everywhere, from our smartphones to our homes. Well, imagine combining the power of AI with the mind-bending capabilities of quantum computing. That's right, we're talking about quantum AI, a fusion that could redefine the future. See, AI relies heavily on crunching massive amounts of data to learn and make predictions. It needs to process information at lightning speed. And guess what's really good at crunching massive amounts of data? You got it, quantum computers. These machines can handle computations that would take classical computers millennia to solve. So, by using quantum algorithms, we could potentially train AI models way faster and make them even smarter, more efficient, and more accurate. We could see breakthroughs in everything from medical diagnoses to self-driving cars, making our lives safer and more convenient. But hold your horses, we're not quite there yet. The technology is still in its infancy. Quantum computers still need to mature a lot before they can handle the complexity of real-world AI problems. The road ahead is long and challenging. But the potential is there, and it's pretty mind-blowing. Imagine a world where AI and quantum computing work hand in hand to solve the unsolvable. Now, before you go throwing out your laptop, let's be clear. Quantum computers aren't here to replace our trusty classical computers entirely, at least not anytime soon. Think of it like this. A classical computer is like your everyday car. It's reliable, versatile, and gets you where you need to go. A quantum computer, on the other hand, is like a supersonic jet. It's incredibly powerful and can reach incredible speeds, but it's not exactly practical for your daily commute. Quantum computers are best suited for specific tasks that involve complex calculations, like simulating molecules or optimizing logistics. For everyday tasks like browsing the web or editing documents, your good old classical computer will do just fine. Alright, let's talk about the internet. More specifically, the quantum internet. Imagine a network so secure that hacking is literally impossible. That's the promise of the quantum internet. It would use the principles of quantum mechanics to transmit information in a way that's fundamentally tamper-proof. Think of it like this. If someone tries to eavesdrop on a quantum communication, the act of eavesdropping itself would alter the message, making it obvious that someone's listening in. Pretty cool, right? But building a global quantum internet is a massive undertaking. It would require overcoming huge technical hurdles, like figuring out how to transmit quantum information over long distances without it getting garbled. Now, you know, a technology is a big deal when the biggest names in tech are pouring billions of dollars into it. And that's exactly what's happening with quantum computing. We're talking about companies like Google, IBM, Microsoft, and a whole bunch of startups you've probably never heard of yet. They're all racing to build the first commercially viable quantum computer. It's like the Wild West of computing, with everyone vying for a piece of the quantum pie. And while it's still early days, the sheer amount of investment shows just how much potential these companies see in quantum computing. Now, let's talk about something that could have a real impact on our lives. Medicine. Quantum computers have the potential to revolutionize healthcare by accelerating drug discovery and enabling personalized medicine. See, simulating how molecules interact is incredibly complex. It's like trying to predict the weather, but on a molecular scale. But quantum computers can handle that complexity, allowing scientists to design new drugs and therapies with much greater precision. Imagine developing life-saving drugs in a fraction of the time it takes today. Or even creating personalized treatments tailored to your unique genetic makeup. That's the power of quantum computing in medicine. Here's a fun fact. Quantum computers are kind of like penguins. They needed to be super cold to function properly, like really cold. We're talking about temperatures close to absolute zero, which is minus 459.67 degrees Fahrenheit. Why so chilly? Well, remember how sensitive those qubits are? Any heat or vibration can mess them up. So to keep them stable, quantum computers need to be kept in these giant, super-cooled fridges called dilution refrigerators. It's one of the biggest engineering challenges in quantum computing, and it's one of the reasons why you won't see a quantum computer in your living room anytime soon. For our final fact, let's take things to the final frontier space. That's right, even NASA is getting in on the quantum action. They're exploring how quantum computers could be used to solve some of the biggest challenges in space exploration. Think about it. Space travel involves a ton of complex calculations, from plotting trajectories to analyzing astronomical data. And quantum computers could potentially do all of that much faster and more efficiently than our current computers. We could see missions to Mars planned with unprecedented accuracy, or even real-time analysis of data from distant galaxies. The possibilities are truly astronomical. So there you have it, 10 mind-blowing facts about quantum computing. It's a field that's still in its early stages, but it has the potential to revolutionize everything from medicine to space exploration. It's a future full of possibilities, and I, for one, am incredibly excited to see what the quantum future holds. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating insights into the world of technology. And be sure to let me know in the comments what other tech topics you'd like me to cover in future videos. See you next time.